So I will be presenting this talk today on behalf of Andres George. She was originally slated to present this, but was unfortunately not able to make it. So I'll be giving her talk for her. And this is actually on behalf of several other people who have worked on this project, all these people mentioned here. I'll start the talk with a brief introduction to Orion. I'll talk about its multi-tiered storage architecture and some of the Lustre specifics of Orion itself. Then I'll go into a little bit of the file system characteristics, the composition utilization, and finish up with some information on the prevalent I/O patterns that we have seen on Orion. So Frontier is the first of 3 exascale systems being deployed by the U.S. Department of Energy. So Frontier's been in production for over a year now, and its main storage system is the Lustre file system Orion. In fact, that's the new center-wide file system for the systems at OLCF. Orion is based on HPE Cray's ClusterStor E1000 storage platform. The Orion file system is a multi-tiered storage architecture. We have 3 tiers. We have the metadata tier, a performance tier, and a capacity tier. The metadata tier is used, obviously, to store all the file metadata, in addition to storing a little bit of each file on there using the DOM feature of Lustre. The performance tier consists of OSTs that are all NVMe based, and those primarily store files that are a few megabytes in sizes. And then the capacity tier, which is our largest tier, holds the majority of data for our larger files. Here in the table, you can see the capacity for each tier that we have listed. So we're looking at a total file system size of just under 700 petabytes. The bandwidths that are listed here, these are what we originally had spec'd in the RFP for these tiers after running some of the benchmarks during acceptance. I don't know if we have any more recent numbers, but some of the numbers I had from last year, we found that we were fairly closely hitting all of these performance numbers. For the performance tier, we were actually exceeding our target for reads, and we were hitting 13 terabytes a second, while our writes were just under 10, like 9.4 terabytes a second. At the capacity tier, we had reads that were at about 5.3 terabytes per second, and we had writes that were just at like 5 terabytes per second. So we were pretty close to what our spec targets were for this. This is a visual representation of the multi-tiered architecture. You see at the MDT tier, we have 40 MDSs, each of which hosts a single MDT, and each MDT is comprised of 12 NVMe drives. And then each OSS actually serves out 3 OSTs. One of those OSTs is all NVMe based, and that's part of the performance tier. It also consists of 12 NVMe drives. And on that OSS, there are also 2 hard drive based OSTs, and each of those is comprised of 53 hard drives. So in total, our performance tier has 450 OSTs, and the capacity tier has 900 OSTs. The backend file system for all of our targets is ZFS. We're using version 2.1.7. For the redundancy, we're using the ZFS DRAID. This table shows the configuration of the DRAID for each of the MDTs and OSTs. So both the performance tier OST as well as the MDT, those consist of 12 drives. They're set up with 9 data blocks, 2 parity, and 1 spare, while the hard drive-based OSTs that consist of 53 drives, they're configured with sort of 11 data blocks to 2 parity drives and a total capacity of about 2 spares for that OST. The sizes of the drives in each tier, even though the MDT tier and the performance OST tier are both all NVMe based, we actually use different capacity drives for those. We have 30 terabyte drives for the MDTs, and then we use 3.2 terabyte drives for the OST performance tier. As far as the Lustre as far as the Lustre specifications on Orion goes, we are using Lustre 2.15 with some vendor patches. The OSTs themselves are grouped into two pools, which are aptly named performance and capacity. We make use of the distributed namespace feature to spread our project directories across the MDTs. Right now, we are only utilizing remote directories, so the DNE1 at this point. And so we sort of manually distribute those across the different MDTs as we get new projects. We don't do Stripe directories yet. That's something that's under investigation that we may deploy sometime in the future. And then for the file layouts, we take advantage of several of Lustre's more advanced features. We use data on MDT or DOM. We use the self-extending layouts feature as well as progressive file layouts. This table kind of shows the default layout that we use for files on Orion. It's a PFL layout, and it's intended to accommodate a wide range of I/O patterns and file sizes. It's not necessarily intended to be optimal for everything, but rather a reasonable configuration if a user decides to run and doesn't make any modifications on their own. We try to come up with something that will work fairly well for the user, as well as making sure that data gets distributed in a reasonable manner. You don't have a user generating a large file on a single OST. And the way we set it up is we have the DOM component takes the first 256K of the file that will reside on the metadata servers themselves. Beyond that, up to 8 megabytes goes to the performance tier. And then once we hit 8 megabytes up to 128 gigabytes, that then spills over to the capacity tier with just a single stripe count at that point. And once we get beyond 128 gigabytes, we still remain on the capacity tier, but then we increase the stripe count to 8. So we spread the file out a little bit wider. One of the other things we do take advantage of is the self-extending layout feature to help kind of protect against the situation where a user might fill up, an OST by accident, or rather that not so much a single user, but rather the aggregate usage of all users can start filling up like a specific OST or a specific tier, and then that can, of course, cause potential I/O errors for other users. So we define an extension size for each of these components. On the performance tier, the extension size is 64 megs. Now, this is a lot bigger than the total 8 megs that we would put on that tier. That's just because 64 megs is the smallest extension size that we can use. When we get to the capacity tier, that first component, we do an extension size of 16 gigs. And then for the final component, we increase that to 256 gigs. We kept these quite large so that we don't have, as the files grow, we don't have a lot of repeated requests to keep extending the files. So there should be relatively few requests to keep, extending these files as the file grows, but enough of them that if for some reason an OST is filling up, that we can then sort of prevent the user from getting an I/O error. So we profiled some of the file system information using the fprof tool. This information was gathered around mid-March of this year. It's a way of traversing the file system, and it gathers stats about, total number of files, sizes, things like that. At the time that this was run, the total utilization of the file system was about 31%. You can see we had the total numbers of files was about 2.9 billion. That's actually increased more recently. We're getting closer to 3.8 billion files on Orion. We have 100 million directories, 60 million symlinks. Average file size is only about 70 megabytes. And the average number of entries per directory is 29. And then the aggregated file size across all of our files was just under 200 petabytes. Using this information, we were also able to take a look at how the file system was utilized based on projects. So right now we have about 488 project directories on Orion. The usage for those directories is mapped to their respective science domains. This is taken from when users request an allocation, their request is within a specific science field. So it's broken down by the predetermined categories that we have for the allocation process. The largest of which is physics, which is about 40 petabytes and about 22% of our utilization. And then that's followed second and third by fluid dynamics and astrophysics, at just over 20 petabytes for fluid dynamics and just under 20 for astrophysics. And then we have several following up. We have climate, geosciences, accelerator physics, as well as some vendor-related projects and staff-related projects in there. For the file size distribution, FPROF shows us how many files are in different sized buckets. So we can see that 30% of these files are in the sort of 0 to 4K bucket. So that's by far the largest bucket as far as total numbers of files goes. And then we see the next common ranges are in the 64 to 256K size and the 16 to 512 megabyte size. Each of those constitutes about 11% of usage as far as file count goes. And then files that are larger than 256 gigs are fairly scarce. We have about 90,000 of those. Now, this is based purely on file counts. It's not file usage. If you actually look at the file usage, that small number of large files, even though files over 256 gigs barely makes a blip on this graph, it accounts for over 20 petabytes of the data residing on the file system. We also looked at some information from Darshan logs from October to December of last year. These Darshan logs take into account the cumulative I/O overall interfaces. That includes standard I/O, MPIO, and POSIX on compute nodes. And you can see, so these are graphed for weeks 39 through 52, so the last 3 months of the end of last year. You can see that by about the third week of this, the write operations had reached nearly 10 trillion cumulative operations, and the read operations also exhibited consistent growth, reaching up to 1 trillion. And over a 3-month period, we had transferred in writes nearly 10 petabytes of data, and the reads was somewhat over a petabyte. The Darshan data is also used to look at the read-write call distributions for these weeks. As you can see, there's quite a lot of variance in the percentage of read and write calls. It's difficult to observe any sort of fixed trend for these. If you look at the percentage of operations, there are weeks that are nearly completely dominated by writes and others that are completely dominated by reads, with a few in there that sort of have unequal balance. And as far as number of bytes transferred, we do see that writes are basically dominating most of the time. There are only 4 weeks in there where the reads were dominating the number of bytes that were transferred. I should mention this Darshan data doesn't necessarily encompass 100% of the jobs on Frontier. It's enabled by default, but users can disable it, or there could be other reasons why Darshan data isn't collected. Based on usage from the previous system, Alpine, it was estimated that we had about 40% coverage for the Darshan data. So assuming that still holds, this data represents about 40% of the jobs that were run on Frontier. And so we also looked at the I/O request sizes and file sizes used by various workloads. These graphs show the cumulative distribution functions. On the left, we have the I/O request sizes for reads and writes. There we can see that the write request size is larger than the read request size. The majority, of those I/O request sizes are, fairly small. They're not really huge. On the right, we have the file sizes themselves, and there we also see the majority of files that are read and write are under a gigabyte. The small zoom in plot here is basically cuts off that first data point, so you can see a little bit clearer what happens near the cusp there, and you can see a slight difference with the writes, that there are still some significant write files that go up to like 10 gigabytes. So in summary, Orion has been operational for over a year. We've been catering to various I/O needs for lots of data-intensive HPC applications. We have over 2.9 billion files, actually closer to 3.8 billion right now, and 100 million directories. Current utilization is 31%. I suspect that's slightly higher now since the data was gathered in mid-March. But a large percentage of our files, over 30%, are under 4K, and we have very few really large files, over 256 gigs. Although the few that we have do constitute a fair amount of our total usage for the file system. We found that read and write calls are mostly balanced, with writes dominating in some instance, and the weekly dominance of the read and write calls, based on the Darshan data, we were able to determine that those are we are getting an indication that we have a lot of large-scale jobs running on the majority of Frontier's nodes that are accounting for the data that was represented here. And majority of files that are read and write are under a gigabyte in size. I want to acknowledge the DOE support for the Oak Ridge Leadership Computing Facility, and I'll do my best to answer any questions that I have. If not, I can get you in contact with Angus, who can probably fill in anything that I can't answer.
Questions right here?
So your PFL layout, how does that work out with DOM versus like the capacity that's available on the MDTs? Do you have any kind of idea of like, are the MDTs filling at about the same rate as your performance or your capacity tier?
I don't know. Do you happen to know, Jesse, about the ratio of?
MDTs are roughly like, sorry, let me double check. I thought it's like 10 to 15%, but let me double check.
Yeah, I guess actually I'm going to switch back real quick. The one thing I did forget to mention on this table too, the reason that we chose it as we did is this was based off of Alpine usage information based on the file size distribution there. We were using that to figure out roughly what we expected on Orion, determine where we should set some of these thresholds at. And it was based off this idea that we expected about 70% of files were going to be like 256K or less, and 18% were going to be under like 8 megs. So that's kind of where we came up with these numbers.
Okay, I was just thinking, I mean, we've seen a few times where, with data on MDT, people essentially expect the worst case usage scenario where it's like, 256K, so every file is going to use 256K. But in fact, like some large fraction of your files are only 4K. And so in fact, you could bump that up to, 384 or 512 or something like that to keep the ratio of usage. So your DOM isn't sitting at 10% and the rest of your file system is at 90% or something like that. So you can adjust your PFL ratios as you get more experience with that.
Yeah, it's possible that this could be adjusted at some point in the future. When we came up with this was early on before we went into production, and we were trying to just come with the rough idea, like if we have the same distribution, like how much could we afford to keep on DOM, and how much should we allow on the performance tier? We were estimating if we got up to like 10 billion files, how much could we afford to have on each tier without the possibility of filling up and things like that. So yeah, as we're in production, we get more usage information. We might find that some of these divisions should be tweaked.
Yeah, and if I remember right, when we did the calculations for DOM sizing, like 512 would have been like pretty much ideal. But Dustin and I are both pretty conservative when it comes to estimates, and neither of us were comfortable with like making that right. Yeah,
yeah. These are conservative values because we didn't, till we get things up and running and we got purges running. We wanted to play it on the safe side and not risk having like the performance tier fill up and people not be able to run. So yeah, these are probably a little more conservative than they need to be.
Over here. Question, Rick? Back here.
Oh, back.
Twofold. Can a specific user get permission to bypass the PFL and write only to the performance tier? And as your previous class of systems deployed, has your file distribution dramatically changed with Orion compared to Summit or Alpine or even previous generation file systems deployed?
I don't know about the comparison of the file size distribution for previous generations. I haven't looked at the Alpine data, so I don't know. I'd have to. Do you happen to know, Jesse? Okay, so it sounds like right now it's pretty similar. Let's see long term whether that. Yeah. Yeah. So, and the first part of your question was user. Yes. Even though we don't want them to, there's nothing that we can much do to stop a user from changing it. If they. Yeah, I saw that that was a patch that was coming out that could control it. For the most part, we're relying on the fact that users tend to be lazy and don't make a change. And so that's really what we're targeting with the PFL. In fact, if a user knows what they're doing, we want them to use a layout that will optimize their application, because this layout is not intended to do that. This is for the lazy users. Yeah. Yeah. Oh, did you get that finished? Yeah. Okay. So yeah, just been working on a LFS wrapper around this so that if users do run that, it can apply restrictions of various, things. Because we have run into issues, one of which involves, I think it's most likely users that have like old code that is used to previous file systems that we didn't have multiple tiers. So we didn't have OST pools. So they want to set a file. They just do LFS, set stripe, and they give it count 10. The way that inheritance works with these layouts, because the PFL is the default, it wants to inherit things from that PFL layout. And in particular, it will go to the first component, the first non-DOM component of the PFL layout. So when they say, give me a stripe count 10 file, Lustre looks and says, oh, well, let's see, what default should I inherit? And the first thing it sees is that the OST pool is set to the performance tier in the first PFL component, non-DOM component. And so it immediately creates the file on the performance tier, even though the user didn't request it. So that has resulted in files getting created inadvertently only on the performance tier. And so we've had to deal with things like that. And that's where the wrapper comes into play.
Mike Solari from NREL. From an operational point of view, you've been up a year, so I presume you've upgraded Neo in that year, the operating system on ClusterStor. Are you able to do it online, or do you take downtime? Gotcha. How often do you take downtime on it? Okay. It's consistent with us.
Yeah.
I just was hoping I'd get more.
I should also mention, even it's a cluster project, we don't run the full standard like Neo stack that would come with the product. We have the way we run our systems and do like security constraints that like our deployment uses a lot of our own provisioning stuff, but we've worked with HPE and we deploy parts of their software on the systems. We just don't do like the whole standard Neo stack. So we don't go through like the CSCLI to manage things. We don't have that tool. We use Puppet, like we have diskless boot, we have Puppet that pushes out configurations, things like that. We have our own monitoring that's running on there, but we still use a lot of the failover configurations that they had in place. Some of their specific, disk monitoring tools, things like that, those have been deployed. So we've got parts of their software on the system.
Thank you.
Yes. Kurt Stroessel, Jefferson Lab. I had a question about your capacity pool.
Yes.
You were using the D-RAID for that.
Yep.
Have you seen any issues with like long mount times or long recovery times because your OSTs are so huge?
I don't think so. No, I don't think we've really had any issues with that.
Kevin Harms, Argonne. So, Rick, based on the data that you guys have collected and analyzed thus far, would you guys change anything about how Orion's built or configured based on that data? Or maybe you feel like, no, you've addressed it the way you wanted it?
I guess I can give my opinion. Jesse might have a different one. Maybe we might look at I think the original design, our intent was to hopefully use DOM to get performance boost for lots of small files. So we actually made it quite large compared to the performance tier. Hindsight, maybe we didn't need to make the M metadata tier as large, and maybe could have put some more into the performance tier itself to get, files that are maybe 12 megabytes or whatever, slightly larger, on that tier. It's hard to say. Part of the benefit of it too is not so much performance gain for small files as it is keeping small IO off of the other OST so it doesn't necessarily interfere with them. So, it's hard to say whether that was the right choice or not. That's one possibility. I don't know would you change some things, Jesse? Okay.
Any other questions? If not, let's thank Rick Mohr. Thank you.